Hey guys, welcome to lesson 6.1, where we talk about discrete random variables and expected value. So random variable is a number attached to each outcome of a random circumstance. A probability model is a listing of possible values and their probabilities. So for example, if you play the lottery, you've got different odds of winning different prizes. So every probability is a number between 0 and 1. And all the probabilities add up to 100%. So for example, we have a lottery A where you have a couple big winners. So you have one chance, there's 500 tickets and $1,000 in prizes. So you have one $500 prize, you have four $100 prizes, and you have five $20 prizes. So altogether, you have the 10 winners and you have $1,000 in prizes. Now, the odds of winning a prize are about 2% total, which means that 490 out of 500 people that play the lottery, or 98% of the people, are going to lose. Now, if you end up, let's look at the expected value of playing, right? Because you might win $500 or you might win $100. And depending on depending on how much it costs to play, this might end up being a good play or a bad play in terms of expected value. So like any sort of gambling, risk taking, people talk about expected value, the cost to play and the average amount you win. All right, so expected value, what it means, the average value over many, many repetitions, multiply each value by the probability and add everything up. What it's not, it's not the result of any single play. So it's just the average of average when you do play. A ticket with expected winnings of $2 never actually wins $2, like for example in our scenario. So let's look at the math behind in this situation. So you have $500, the grand prize, but the odds of winning it are 1 out of 500. So basically 1/5 of 1%. So the 500 times the probability gives you expected value of $1 here. The $100 times the probability of 4/5 of 1% gives you 80 cents. And then these are like times. So $20 times 1%, you have a 1% chance of winning $20. So that is an expected value of 20 cents. So altogether, your expected value of playing would be the 500 times 0.02, the 100 times 0.08, times 20 times 0.01. We don't have to do times, 0 times the 98% because 0 times anything is just going to be 0. So altogether, if you add these up, you end up getting $2. So if you play, every time you play, your expected value of what you win is $2. Now, so the question is like, should you play this lottery? Well, if it costs $1 to play and you expect to win $2 every time you play, it's a great deal. But if it costs, anything over $2, if the lottery costs $2, in terms of expected value, it's break even. So it's a good deal if every ticket to the lottery costs less than $2. It's a bad deal if every ticket to the lottery costs more than $2. And, the more, like if it costs $3, then it's like pretty bad deal in terms of expected value. You're basically losing $1 for every time you play. All right, we can have another situation where now, instead of 10 winners, we have 61 winners. So you can win $200, $20, or $10. There's a possibility. There's only one $200 ticket in there. There's 20 $20 tickets, and there's 40 $10 tickets. So what's the expected value of playing? 20 times, or 200 times 0.02, 20 times 0.04, and 10 times 0.08. So now you have roughly, instead of 98% of people losing, now we only have 87.8% of people losing. So a lot more people could win something. The expected value of playing is still $2. So as we said, what's the catch? How much does it cost to play? That's the crux of any sort of gambling situation. What's the expected value of playing times what's the cost of playing? So if the expected net is your expected value of winnings minus the costs. So for example, if the lottery ticket costs $5 and you expect to win $2 every time you play, your net loss is $3 or negative $3 net win. That's a pretty bad situation. But if you have a club and it's doing it and it's just like a raffle situation, then they're basically doing they're collecting $3 to raise funds for whatever, summer camp. So the question is, between the two lotteries, what's the difference? And the difference is standard variation. So in Lottery A, the one that's only has 10 winners, it's super top heavy. It's got a significantly higher standard deviation than the one where you've got 61 winners. So basically more winners, but everybody's still on average. Everybody who plays has an average chance of winning $2, but there's a lot more winners, so it's a smaller standard deviation. So 61 winners, the same of money spread out over many more wins, a much smaller ride. And then in the 10 winner situation, you've got the jackpot experience. A lot of poker tournaments and golf tournaments are super top heavy, so then they can talk about like how much the winner won, and it's like a big news event. Phone insurance. But if you have that situation, that means you have to have like significantly more losers to have the headline about the one winner winning $1 million. I mean, basically it's like, it's a pyramid scheme versus like a more narrow pyramid. Phone insurance, the same two-step logic. So let's say a protection plan costs $150 per year. 8% customers break their phone. That's the expected probability of someone having to collect the insurance. And when they do, they get a $700 replacement. So let's say it costs the company $700 to replace a phone, and the protection plan costs $150 per year. So the expected benefit is the 8% chance of losing $700 for the company, plus, so basically plus 0 times the 92. 92% of the time they don't have to pay anything out. So it costs the company $56 per year on average for a protection plan they issue, but they collect $150 for that. So they're $94 in the clear. Now, for the customer, if they choose to pay $150 for the plan, then they're going to be losing around $94 per year on that. But why a customer might still buy it, avoiding a rare $700 disasters can be worth more than the average suggests. Expected value starts with the decision, it doesn't finish it. Basically, any sort of insurance you get, the people who issue the insurance, the underwriters, figure out the probability of some sort of negative event happening, the cost of the event to the company, and then they put some sort of a premium so they earn money. That's the general idea. So random variable is the number attached to each outcome of a random circumstance. A probability model is a table of possible values and their probabilities. Expected value, it's the long run average. It's also called the mean of a distribution. Expected net is winnings minus the cost. A fair game, it's where the expected net is 0. Insurance is not a fair game. Casino is not a fair game. None of these are fair games. But if you have a fair coin and you and your friend play, basically heads you pay me $1, tails I pay you $1. In terms of probability, we're just going to be exchanging $1 long term. And no one has an edge and no one's going to win. Standard deviation, how far an individual results land from the mean, the size of the ride. So summary for the lesson, your expected value is the probability of an event happening times the impact of that happening. In the situation where you have both lotteries with 500 tickets, both have an expected winning of $2. And after the $5 ticket prize, the expected net loss is $3. That's what the club is going to profit. Standard deviation separates them. When you have one big winner and just fewer winners in generals, it's a higher standard deviation. When you've got more winners, it's a smaller standard deviation. Insurance runs the same 2 steps. You have some sort of probability of an event happening times the amount of money they have to pay out, and then they collect a premium on that. So that's lesson 6.1.